Hello everyone, welcome to Ratios and Proportions. We're going to take a look at a couple of examples here to explain exactly what we mean when we talk about ratios and proportions and how to apply those to different circumstances. So let's look at our first example in here. If we have to express the ratios as equivalent ratio with the smallest term 1 and we round to the nearest 100th, what does this mean? It means we're going to take a look at the smallest number of these three and convert that to 1. Then we're going to take a look at the other two numbers and see how that relates to 1. So what do? Well, we take the 5 first, which is our smallest. We want that to become 1, the lowest term, so we divide it by 1. 5 divided by 5 is 1. Now what do? Well, we say that is going to be the equivalent to 6 divided by 5. We see that that's going to be 1 point something. Now we do the same with the 8. We have to have 8 in its lowest terms relative to the 5. So we divide that by 5 as well. 8 over 5. And the solution then becomes 5 over 5 is 1. And 1 relates to the 6 over 5, which is 1.2, which then relates to the 8 over 5, which is 1.6. So the proportions between 5, 6, and 8 are equivalent to 1, 1.2, and 1.6. Okay, let's move on to solving for some unknowns. If we take a look at these two relationships, we have 17 is to 34 as some unknown is to 150. So how do we solve for the x? Well, we start by putting these into fractional form. So 17 is to 34 as x is to 150. Okay, the relationship between the right and the left side are the same. So how do we solve for x? Well, we cross multiply these numbers and then divide by 34. So we end up with 34 dividing into 17 times 150, which is 2,550. Okay, so 34 goes into 2550 75 times. So we find out that x equals 75. We now can express this as 17 is to 34 as 75 is to 150. And just from visual, you can see that that's correct, because 17 is half of 34, and 75 is half of 150. So you can test that out and see that you've solved the solution. You've come to the solution correctly. All right, let's take another example over here. If we're taking a look at some students, we have Sarah, who got 75% on a test. Mike gets 86% on a test, and Kim gets 98% on their test. Express as a ratio how these relate to each other. Well, all we have to do is identify the relationship. 75, doesn't matter that it's a percent, is to 86, and how that relates then to 98. And that's it. We're just expressing the relationship of these test results to one another. 75 to 86 to 98. One more question to take a look at. This is more everyday life situation. If last year's cost of promotions is $120,000 based on sales of $20 million, and this year's sales are expected to be $35 million, what can we expect the commissions to be this year if the relationship between commissions and sales remains unchanged? Well, let's start with the knowns right now. It's going to be the same sort of question as what we saw over here. We have 120. I'm going to drop those extra zeros just to keep it simple. 120 is to 20,000. See how I've dropped these extra 3 zeros? It keeps it balanced, but easier to write down. So 120 is to 20,000 as some unknown commission is to 35 million. And again, I'm going to drop those extra zeros. So we're all talking the same thing, but just simplifying. Okay? So we go ahead and we convert it to a fraction just as we did over in this example. We've got 120 over 20,000 one more zero in there equal x divided by 35,000. You can see why I dropped those extra zeros. It takes a while to write them down. Okay, what do we do to solve? We cross multiply, then divide. 120 times 35,000, all divided by 20,000. So what do we get? Let's write that down. 20,000 divided into 120 times 35,000 is 4, 2, and a whole slew of zeros here. Okay. So 20,000 goes into this 210,000. There we go. So our answer is the commissions on $35 million of sales is going to be 210,000. X equals 210. There you have it. Ratios and proportions.